So let's move into ENSO theories. As I said, theories is not very comforting because it means we don't have one unique theory that works for all situations or all El Niños or explains all of the El Niño. This is showing three states of the equatorial Pacific Ocean for neutral conditions, warm event and cold event. Bold arrow denotes wind anomalies, which is during neutral conditions, is balancing the sea level slope with the thermocline slope. During El Nino, you have weaker winds, so you have shallowing of the thermocline and flattening of the thermocline. So you get negative sea level anomalies here, positive thermocline anomalies, and you get anomalous flow eastward, and especially near the surface, and you get a positive sea level anomaly here. So remember, cold temperatures, high pressure, low sea level, shallow thermocline like this. During an El Nino it's reversed, and during La Nina you exaggerate the sea level slope and the thermocline slope, right? The thermocline slope is something we defined in chapter 6, where there is a level of no more. So we had looked at kind of a reduced gravity situation with the deep motionless ocean with the active layer on top, and we had looked at pressure gradients within that layer. The deeper layer had the density rho 0, and then we had rho 1 and rho 2 in the upper layer, and then we had defined the depth of the thermocline essentially as balancing the flow within the upper layer. The deep layer has to remain motionless, and so on and so forth. But you get the picture here. So this is exactly what happens. The idea of Bjerknes was that he was the first one to realize that the El Nino and the Southern Oscillation as proposed by Walker were essentially the same, and this was because there was a close coupled interaction between the atmosphere and the ocean. So if you think of a cold phase, for example, you have somehow stronger trades and Hadley circulation. We don't have any idea what that is caused by. You just start the loop by somehow strengthening the trades and the Hadley circulation, which leads to increased convective heating in the West Pacific, strong upwelling, strong push of the cold tongue towards the west, more convection in the east. You have increased equatorial easterlies, and that's what is meant by stronger trades. Enhanced upwelling in the East Pacific and downwelling in the West Pacific, and warmer West Pacific, cooler East Pacific, and enhanced Walker. So this is a positive feedback loop, because if you increase equatorial easterlies, you will increase upwelling, you will cool the sea surface temperature, you will increase the east-west SST gradient, you will make the winds even stronger, make the upwelling even stronger, make the convection stronger, and so on. So you get into this positive feedback loop, which gives you the cold phase or the La Nina. On the other hand, somehow if magically the trades got weaker, we will see that there is also a possibility of doing something on the west with these westerly wind anomalies, wind bursts as we call them, but not always. Weaker trades and Hadley circulation, decreased convective heating in the West Pacific, decreased equatorial easterlies, enhanced upwelling in the West Pacific and downwelling in the East Pacific. So East Pacific has mean upwelling, but it will be weakened. So there is an anomalous downwelling, which leads to warmer East Pacific and colder West Pacific, which is going to make the sea surface temperature gradient weaker, which is going to further weaken the winds, further weaken the upwelling, further warm the SSTs in the east, and further weaken the SST gradient, east-west SST gradient, and so on. So you are again in another positive feedback loop that's going the other way, giving you the warm phase. So what turns off this growing positive feedback that is going in the La Nina direction or the El Nino direction then? For this, Several theories have been proposed, which basically look at negative feedbacks, and we will look at three of them. One is called the delayed oscillator, other one is called recharge discharge oscillator, and there are others which are not as popular but still called West Pacific recharge oscillator, and a advective advective wave oscillator or some such thing that we will look at, but that one is not caught on after it was proposed many years ago, I think in the 1990s by Joel Picot, who was one of the guys who was involved in a lot of the El Nino related field campaigns in the Western Pacific and so on, that were produced lots of insights on all time scales in terms of convection, air-sea exchanges, vertical structure of the ocean, etc., which we will get on into the later chapters. Okay, so Bjerknes feedback is a key process, and we will see later on that even in the Indian Ocean and the Atlantic Ocean, where there are El Niños, the strong zonal modes there, known as the Indian Ocean dipole or the Atlantic Niño, also have this feedback. The key that's not explicitly stated here is that when there is a strong upwelling or reduced upwelling, the cooling and warming of the SST is not just because of heat fluxes. It's actually because of the interaction between the thermocline entrainment of cold water or reduced entrainment of cold water that changes the sea surface temperature. So this interaction between the thermocline and the mixed layer or the surface layer is a critical part of the Bjerknes feedback, and that's what brings in the important role of the ocean in the coupled ocean atmosphere phenomenon of El Nino and La Nina. There is a little bit of debate about whether this coupling of the ocean and atmosphere is really necessary, or you can just do it by surface fluxes without involving actively the ocean dynamics. That's called a thermally coupled mode, and some of the weak El Niños look like maybe they're happening just by the air-sea interactions, but by all accounts it seems like all the El Niños and La Niñas are involving this Bjerknes feedback. The idea of what weakens the trade winds or strengthens the trade winds is a little bit more complicated. We have to add also the idea of how the warm water that's stored in the ocean is going to be released during a La Nina, and how that may be related to trade winds and when that onset of the discharge happens and so on. Essentially lots of unanswered questions, but we will nonetheless look at these theories and see how much the theories explain and how they try to do that. The main point being that the Bjerknes feedback has only a positive feedback, but at some point the El Nino and the La Nina have to terminate, so you need a negative feedback, and these theories basically give you negative feedbacks in terms of ocean currents and waves. That's the critical part. Okay.